guys, in this tutorial I will explain how to make a third-person character control system using the new GameMachine tool, a node-based tool for visually scripting game logic. Okay, first we import the character asset provided with the basic package of S2ENGINE. In the prefabs browser, the system creates a new folder called characters. In this folder we will find a new file called marine.so2. This file contains the description of the object and reference to the model and animations. We drag and drop the object inside our scene. Click right mouse button on the object and select the first item in the drop menu. This is the source model of the object. In the model animations tool, we can see the list of all animations attached to the model. We can select one of them and see the object animating by clicking play on the animations track tool. We now add to the model a new animation item, monodimensional blended animation, that blends two or more animation sequences based on a blend float value. We add to the blend item 3 animations from standby to run. We can test the animation using the Blend It slider. Now we create a new GameMachine asset for making our character finite state machine that control its logic. After creating the asset, we load it into the character object and apply the change. Click on the right mouse button on the character object. A drop-down menu will appear and we select the finite state machine asset loaded into the character. We add a new state in the finite state machine of the character and we call it stand. In the anim panel of the state, we select the previously created blend animation. We add the global transition start to the stand state to make this state executed at start. When apply changes, the state works and character executes the selected animation. We can easily change the animation of the state and reapply the changes to make character playing the new animation. Now we create a new camera object, selecting camera from the creation panel and click the create button. We see camera object parameters. In our case, we make camera activable. That means camera be activated at start. By clicking in scene, camera object will be placed. And then we again click on the create button for exiting from creation phase. Now we define the input mapping for character movements and camera rotation control. Click on the input mapper tool icon. We add a new input axis for mapping character forward movement using a keyboard or a gamepad. We define W, K and SK respectively for forward and backward movement. Now we define input for right movement, adding a new input axis that we call move right, and add A and D keys for respectively left and right movement. Finally, we define input for camera rotation by adding two input axes, one called turn up and one turn right. Turn up for camera pitch rotation and turn right for camera yaw rotation. We add mouse Y for turn up camera and mouse X for turn right camera. Now we create a new GameMachine asset for camera logic inside the character folder. As for the character object, we load it into the camera object. As for the character finite state machine, in the camera finite state machine we add a new state called stand and make it the start state. Now we add the actions to camera stand state and making it orbiting around character. First we add get input axis action for retrieving horizontal and vertical mouse displacement according to the defined input mapping. We store the value from input axis into two variables, one for camera horizontal orbiting and one for the camera vertical orbiting. These two variables will contain the relative displacement of the mouse, and we use them as input for the orbit action. So camera, we rotate around the character basing on mouse movement. I add now a new action called orbit that makes camera orbiting around the character, basing on orbit x and orbit y value. I change target distance parameter in order to make camera to be at right distance from character. We change the parameter frame time into the orbit action to false in order to make camera not moving according to the frame rate. We eventually can change the horizontal or vertical camera displacement respect to the target character as we like. Now we edit stand state of a character think state machine for making him rotating and moving coherently with the camera movements. We define two variables, forward speed and right speed, that store forward and right character velocity, basing on input axis value we have defined into the input mapper. We add two actions into the stand state of the character that get the input axis values to store inside the defined variables. We can also add a multiplier to the input axis value, in our case 300, that is the maximum speed of character. Now we add a new action called set orientation from camera that make character to orientate respect the camera direction, so that when forward speed variable has a value greater than 0, character forward vector becomes the same as camera forward vector, and when right speed variable value is greater than 0, character forward vector become the same as camera right vector. As you can see, I'm changing character orientation using up, down, left, right arrows or keyboard. I add now a bit of smooth in character changing direction. Now I add two new variables that store respectively character motion direction vector and character speed. I add a new action for retrieving character orthonormal basis, composed by the three axes forward, right and up. So I can store in motion dir variable the forward axis of the character. You can see as a motion dir variable change during runtime test. I add a new variable called the target speed. In this variable, I store the max value between forward speed and right speed. So, target speed variable always contains the maximum character speed. To make this, I add a new action called maxFloat that computes the maximum value between two floats. In our case, I compute the maximum value between forward speed and right speed and store the result inside target speed. You can see this during the runtime test. Finally, we add the action for character physical moving by using character move action and passing to it in input motion dir variable and the target speed variable as character speed in forward direction. As you can see, I have forgotten to zeros speed x and speed y action parameters, so character also move on x and y axis. I can adjust it by zeros the parameters. Now we can make character animation we have just created before to blend basing on character speed from standby to run. We take care to make maximum blend x value to match the defined character speed, in our case 300. Now I add a new action that smooths the target speed value when it changes and store the new value inside the speed variable. And replace the target speed variable inside the character move action. The effect of this change is that character speed will change smoothly. Finally, we try to make character animation speed changing basing on character speed. So we assign target speed variable to the speed of character animation. As you can see, the first result is not very good because I forgot to set the speed multiplier matching the character maximum speed. For a better result, we now use speed variable instead of target speed, because the speed variable is smoothed. So animation speed and blending will change smoothly. Then we can see the final result. In the next tutorial, we'll see how to improve character control logic by adding new states and transitions for making it aiming and shooting. Okay guys, that's all for now. Bye.